Good morning, guys. Today we are going to continue with the topic about vectors. This time I will teach you how to add vectors. Now take a look here in this drawing. Actually it's a coordinate plane. This is the y-axis, positive, negative. The x-axis, positive, negative. If you take a look, we have two vectors, A and D. Now, if I say, guys, let's add these two vectors, you might be probably thinking that it's very easy just to add 6.5 plus 8.5. But let me tell you a bad story. It isn't. But the good story is that we have SOHCAHTOA to help us add these vectors. Now, the method that I will teach you today, it's called components method, because we're gonna take the vectors individually and we're going to get its components for each vector. Take a look here. We have two vectors, A and D. So my first row is gonna be my first vector, which is A, and my second row, it's gonna be related to my second vector, which is D. Now this arrow above the letter, above the vector's name, indicates that we are dealing with vectors. Now if you take a look closer, you will notice that we have the vector size, which is the magnitude, but we also have those angles. So the first step to add vectors is to build a table like the one I have here, where in the first column you will have vector, in the second column you will have your x component, and in the third column you will have the y component. Now in the last rows you're gonna do the sum of your x components and the sum of your y components. Afterward you will continue to get your resultant by plugging in what you got in these two cells, okay, and the angle. Now if you take a look, the first vector, I can draw it here, and it's gonna be something like this. I have that it has a size of 8.5, but also has an angle equals 40 degrees. Now, as I already told you, I suggest that you complete your triangle, your right triangle, by imagining a vertical line and a horizontal line, just like I'm doing here. I will do my horizontal line in a different color. Now, my x component is the one that is over the x-axis. That is the green one. So I'm gonna place it here in green. Now, where is my x component going? Is it going to the right or to the left? If you take a look at the arrow, it's pointed out upward but also to the right, so it means that my x component is going in this direction, to the right. As it is going to the right direction, the symbol will be positive. Now, my x component is, as you can see, is touching my angle. That means that my x component is my adjacent side. As it is adjacent, we must use cosine in the trigonometric functions because it's the one that relates the adjacent. So my y component, the formula to get the y component, the x component, will be, so this vector is called a, so my ax is gonna be equal to my vector a. As we're talking about the adjacent side, we'll use cosine of the angle. The angle that we are talking about is 40. So this is going to be equal to 8.5 cos 40. And this gives you, you can use your calculator like this, 8.5 cosine of 40. Make sure that it's in degrees. So I got 6.51. My x component here is 6.51. Now we're going to the y component. As you can see, the y component is the one that is in front of my angle, and it's in blue. As it is in front, we consider this to be the opposite side to my angle, and it's vertical, and as it is going upward, because it's going upward but also to the right, we can say that the y component is positive. As it is in front of my angle, we can also say that this side, according to my angle, is the opposite of the sides. As we have the opposite side, we're going to use sine, because sine is the trigonometric function that relates opposite side. So we say your component y of your vector a is going to be equal to your hypotenuse, which is a, times sine of the angle, and this is equal to 8.5 sine of 40. Get your calculator and do the math. 8.5 sine 40 gives me 5.46. 5.46. We finished the first vector, but that's not it. We need to continue with the second vector. Now, if you take a quick look to it, you can see that the vector v is going upward too, but this time is no longer going to right, it's going to the left. So, in the first step, with the second vector, of course, we're gonna do a drawing for the vector d. It should look exactly like the one that we have right there. So I have an arrow and I have my angle, which is equal to 30 degrees. As I tell you in some other times, we better complete the triangle. You can use dashed lines to complete the triangle. Now this is my horizontal component, and my vertical component is right here. Now you can see that we have the right triangle already drawn. Now what is the size of my vector? Is 6.5. Later we'll talk about the units. So far we're working just with these numbers. Now, where is my x component going? As you can see, my x component is the one that is over x, over your horizontal axis, and it's pointed up to the left. Okay, it's pointed out to the left. So we say, okay, our x component is going to the left. As it is going to the left, the symbol is negative. Now, if you see, the horizontal component is touching my angle. As it touches my angle, is adjacent. As it is adjacent, we're going to use cosine. So we say dx, the component over the x-axis for the vector d is equal to d cos of the angle, which is 30. So this will be 6.5 cos 30. This is equal to, do the math, 5.63 rounded. 9 gives 1 to 2, and 2 becomes 3. So 5.63. Now our vertical component, as you can see, it's going upward. It's going upward. It's in the positive side of y. Take a look. Both of them are in the positive side of y. So it's going upward. So it's positive. Now, my vertical component is in front of the angle. As it is in front of the angle, we are talking about an opposite side. As we were talking about an opposite side, we're going to use sine. And we say my component in y for the vector d is vector d, or the hypotenuse, sine of 30. So this is equal to 6.5 sine of 30. So this should be 3.25. Let's see what happens. 6.5 sine of 30, 3.25, because the sine of 40 is 0.5. Now this is 3.25. Now what happens? Remember that we said about the symbols. We said the first one is positive, so this is positive 6.51. The second one is negative, so this is negative 5.63. These two, both of them are positive and positive. Now what do we do? We're going to add them in columns. Here, your x component will be equal to, you add them both, 6.51 plus, now as you can see, the second component, the second vector, got a negative 5.63. So you're going to add positive and negative makes a negative, makes a subtraction. So basically we're going to subtract, and my x component gives me 0.88. If you take a look, the units for both vectors is meter per second square. Now for my y component, what I do is, as you can see, both are positive, you just add them. So it's going to be 5.46 plus 3.25. This gives me 8.71 meters over second square. Okay, so far we have the components of my resultant. The resultant of adding two vectors is another vector. Now, what does this mean? This means that my resultant is moving 0.88 positive in the positive side of x. Let's say it is right there, and it's moving 8.71 in the positive side of y. So it's gonna be like that, 0.88, and in y we have 8.71. Now my resultant is the line that comes from the beginning to the end of my second vector. Okay, so it's gonna be from the origin to the last one, to the last. So let's say that my resultant should look like that. That is the resultant of adding both vectors. But how big it is? Well, as we have a right triangle, we apply Pythagorean theorem, but adapted to vectors, and we have this formula, which is the same: x to the x squared plus y squared inside square root. So you have the resultant to be equal to the square root of 0.88 to the second power plus 8.71 to the second power. So 0.88 to the second power plus 8.71 to the second power gives me 76.64. Then you get the square root of your answer. So my resultant, as you can see, is 8.75 meters per second square. So that means that this resultant right here measures 8.75 meters over second square. Now, I want to know the angle. So I want to know how much is this angle, the angle of my resultant. So I apply the formula to get the angle, and I say, okay, my angle is equal to arctangent y, the component in y is this one, 8.71, divided by my x component, which is the one in x, 0.88. So this is equal to shift 10 parentheses 8.71 divided by 0.88 close parentheses equal. Take a look. My angle right here is 84.23 degrees. So what does it mean? That the resultant, the result of adding two vectors is the green vector plus the blue vector gives me the pink vector right here. So as it looks like a triangle, well, it doesn't look like a triangle, it is a triangle, a right triangle, we can apply Pythagorean theorem, and after you do that, you can get its angle by relating its opposite and adjacent sides. So, in conclusion, what you have to do is work with the vectors individually, just like we did here. We don't forget about the symbol. Where is my vector going? Where are my components going? If it's going to the right, it's positive. If it's going to the left, it's negative. If it's going upward, it's positive. But in case that is going downward, the y component will be negative. Then what do? You add them individually. In this case, 6.51 plus negative 5.63 is not an addition but a subtraction. So you perform it in the way it is and you get 0.88. As you can see, both of them are positive, so you add them regularly and you will have your answer here. Plus, afterwards you have to get the resultant by using the Pythagorean theorem. This is the same Pythagorean theorem, but it's only rewritten. Okay, it has been rewritten, and the angle that you use, the formula that I gave you the other day. Now this symbol means addition, so that means that we're gonna add the columns. Okay. How many vectors can we add? As much as we have. Example, if we have 20 vectors, we can use the same method. And the result of adding the 20 vectors, for example, it's going to have only two components, x and y, because before you get into this, you should have added them like you did in this step. but it depends on the amount of vectors. So analyze this carefully, and I hope you had understood. Goodbye.